Hello everyone! This video starts a new unit, and I figured I should try and explain exactly, what you should expect in the coming videos, what we're going to be studying, and what we're going to be working on, what the next few videos are going to be about. And I was having a really hard time trying to figure out how to put it into words, and I guess I suppose that'll do it. All right, well, let's get started. So we're still studying similar right triangles, but now we're studying them in right triangles. And in this section, we're going to be talking about self-similar right triangles based on altitude, which is a mouthful, but hopefully you'll see what I mean in some pictures. Let's take a look. So, some vocab to check up on. First, altitude. It's the height of a triangle. Now, normally, if you turn a triangle, there are 3 different altitudes. And that is still true of a right triangle, but only one of those altitudes is not already a side length. So for this set of notes, we'll still need AD as an altitude or AB as an altitude, but please know that AC is the only altitude that isn't also a side length. Next, geometric means. What's that? Well, you may know what a mean or an average is when you add them all up and divide, but a geometric mean is when you multiply them all up and root. So something like 4 times 9 and then square root for an answer of 6. Now, when I referred to self-similarity earlier, I'm talking about this triangle, and this triangle. Those triangles all come from the same figure. However, they're all similar, either by angle-angle similarity, SAS similarity, or because they're right triangles and they can fit HL. So let's take a look at what that means for solving things. Now, before I get into solving the self-similar triangles, I should take a moment to explain what I mean by geometric mean. It's an average. Well, there's the normal average, the arithmetic mean that we're used to seeing, which is adding them all up and dividing by how many you have, but this is multiplying them all up and rooting by how many you have. So I have 2 things, so I'm going to square root, but I'm multiplying instead of adding. So I'll do 16 times 25 and then square root it. This means I get the square root of 400, which is just 20. So a geometric mean is like multiplying everything up instead of adding everything up, and square rooting everything down instead of dividing everything down. The same can be said for 6 and 15. I'll multiply them together, and then I'll square root the result. Now, when I get 6 times 15, I'll have 90, so I have to simplify 90. It does say to simplify the result if possible. We can simplify the square root of 90 since it has a 9 in it. So we can do the square root of 9 times the square root of 10, simplifying our answer to 3 with the square root of 10. This shortcut might be helpful, but let's look at the meat of these notes. Now, when we go to solve self-similar right triangles, we need to be very careful. And in this problem, you'll notice we're just completing a proportion, but that's pretty tricky since I see B in 2 places. In order to make sense of this, we have to dissect the 3 triangles inside of this one. We'll start with the big one. Here I've got A, B, and a length of x plus y. So I'm going to take this triangle and move it aside and label the side lengths A, B, and x plus y. All right, that one's done. Let's move on to the second triangle. Here I have A, H, and Y. So we're going to take that one aside and label its sides A, H, and Y. Now for our third triangle, I'm just going to look at this triangle with the B, X, and H. So the question here is to complete the proportion, and now that we get a little bit clearer idea of what the 3 triangles we can compare are, let's see if there's a comparison we can make. I notice that this fraction, b over x, can be found inside of this triangle, b and x. So the question is, where can I find a fraction that compares to b over x in a different triangle? The answer is over here, where b compares to x. So x compares to b from the small triangle to the large one, but what compares to the hypotenuse b? Well, we have to go to the x plus y value here. Our answer to complete the proportion is the total length, x plus y. The relationships between the side lengths inside of this right triangle are very important, and they're the reason we're able to solve for x and y in this particular problem. We're going to use that idea of the three triangles in order to build a proportion that solves the problem. In order to solve for x, we need that the smallest triangle compared x to 4, while the largest triangle compared x to 20. So the proportion I need in order to solve for x is going to look like this. And when I cross multiply and solve, I am dealing with 80 equals x squared. I'm going to get the square root of 80, and with 80, I can simplify it by multiplying it into 16 times 5. The 16 will square root, and I'll be left with 4 times the square root of 5. For our final answer for x, we'll have 4 times the square root of 5. Now you may be wondering, why did I show you geometric mean earlier if we didn't use it here? Well, it's the shortcut. Notice that I would have gotten the answer for x if I had just done 20 times 4 and square rooted. Now let's take a look at what happens when I try to solve for y. See, I end up with the largest triangle with y and 20, and the middle-sized triangle with y and, well, hold on, it'd be 20, take away 4, so it'd be 16. All right, let's build a proportion between these two. This will also become a geometric mean problem. I'm going to have to cross multiply and square root. Now that I get the square root of 320, I have to simplify. Now 320 can be broken down into 64 times 5. And that simplifies to 8 square roots of 5. So to sum up, an introduction to similar right triangles, we're looking at self-similar right triangles. And keep in mind that there are 3 triangles in one when you draw an altitude. And when you're trying to solve, you need to match up the sides that should go together in order to build a proportion that can be solved with geometric mean. You're cross-multiplying and rooting. That's all for this set of notes. Stay happy, healthy, and safe, and I'll see you in the next one. Bye!